Hello and welcome back to OC Avery. I'm Oliver, and in today's video we're going to be focusing on single factor and double factor dominant mutations in birds. For example, some of the birds I have are single factor and double factor dominant birds. So I'm going to show you a bit about the genetics behind them and how you can understand and work out the percentage chance of producing single factor and double factor birds, and actually the pairings required to produce birds that are single or double factor. So quickly, just to give you a bit of background knowledge on birds that I have that are dominant in single factor and double factor. So the first is a native finch. It's a red poll. So I have cobalt red polls as being one of the mutations of red polls I have. And you can get these in single factor and double factor. And then another bird that I have, which is again a native, is the pied greenfinch. And again, they are a dominant bird, so you can get double factor. So the two examples I've just shown you are both single factor birds. So we've got a single factor cobalt red poll and a single factor pied greenfinch. Now these are both dominant mutations, as I've said. So I want you to look in this top corner. I'm going to show you exactly how to work this out and what makes them single factor. So a single factor can be produced by a different pairing of a bird that is not dominant either way and a bird that is dominant. So take D, the capital D, as dominant, and take the lowercase d as not dominant. It would also be classed as recessive, but I'm just going to say not dominant for this example because it might be a normal you're pairing to, for example. So putting this into a Punnett square, you have large D, little d across the top, and small d on the side, and that will produce you two sets, so 50% chance of producing large D, little d, which would then be single factor dominant mutations, and then 50% little d, which is not dominant, so could be normal or could be whatever you're pairing the bird to. So for this example, I could give you, we have a single factor cobalt red poll, which is big D, little d, to a normal, which is little d, and this would produce us 50% cobalt and 50% normal, which would then be 50% dominant and 50% recessive. That's an example. So you have the single factor and the completely different mutation there. Same goes for pied greenfinch. Obviously, any dominant mutations, that is how to work that out. So I've just showed you how to produce single factored birds. Now, how can you produce double factors? So if you look here again, we have large D as dominant and little d as not dominant. When we put that into a Punnett square, we have large D, little d out across the top and large D, little d down the side. So then when you come to do this pairing, we're pairing two single factor birds. So for example, I'm this year going to be doing cobalt to cobalt. So I'm going to be doing single factor cobalt cock to a single factor cobalt hen, and then this is what it's going to produce us. So in the top corner, we have 25% chance of producing big D, which would therefore be cobalt, which would then make it a double factor cobalt, and we could do that with any other dominant mutation. Then we have a 50% chance of producing single factor cobalt. So then we'll have big D, little d, and big D, little d again, and then that's going to be the single factor dominant birds. And then there is a 25% chance of producing not dominant birds. So for example, me pairing cobalt to cobalt, we're probably going to be ending up with a few normals in there as well. Obviously with dominant as well, it isn't a sex-linked thing, so you can't say it's a sex-linked cock, or it's definitely a hen, because you're not going to know until that bird's molted out and you've looked at that bird a little bit more. So let's say you take one of those double factor birds that you've produced, and you've got a big D, and then it's homozygous dominant. Homozygous means it's the two of the same allele, which is dominant, and it could be heterozygous, which would then therefore be single factor, which would then be big D, little d. Just a bit of biology on that. So if you pair then a double factor bird to a single factor bird, you're going to produce 50% chance of double factor dominant, and a 50% chance of single factor dominant. Now, how can you tell this apart? So two ways in particular that stand out to me are: first, test crossing. So if you get one of your double factor birds and pair that to a recessive bird, which I'm going to talk about a little later on, then you can produce, if it was a double factor, you would only be able to produce dominant single factors and no not dominant colours, if you understand where I'm coming from with that. And the second way, which I've been told about actually with the cobalt red poles, is slightly the different depth of colour. Something I've not got the experience with. I believe a few years ago I did have a pair of double factor red poles, double factor cobalt red poles, but again, I'm a bit unsure and was inexperienced at the time to be a good judge of that. So you just get to see maybe a better depth of colour, but ultimately the best way is test crossing and to see what you've got there. So what if you then pair double factor to double factor? Well, that's quite a simple one. Up here, as you'll see, you've got big D to a big D, and the only thing that's going to produce is double factored birds, because there are no other alleles which will determine that. So you've got the genetics right there on that, and it's going to be 100% chance of only producing dominant birds, which are then double factor dominant birds. So like I mentioned earlier, if I was to then take a double factor dominant bird and put that to a not dominant bird, so I'm going to use the example again, cobalt red pole double factor cock to a normal hen, what would you produce? Well, again, up here you'll see that we've got 100% chance of producing big D, little d, which is therefore single factor dominant in the birds, and then again, no sex-linked inheritance there or anything like that. So you are going to be producing 100% single factor birds and only single factor birds. So why would you choose to actually breed double factor dominant birds? Well, the main reason, I guess, would be actually just for breeding in the future, is that you can guarantee that the youngsters you breed from that are going to be single factor dominant birds. So for example, with the cobalt red poles, I know that if I get a double factor cock to a normal hen, they can only produce me cobalts in single factor. Same for the pied green finch, and again, it doesn't matter whether it's a cock or hen with that instance. Just a bit of something on that as well. There is, I've heard, recessive double factors. Now, I don't quite understand it at the moment with how it all works, but I do believe I've seen of double factor pastel red poles at least, and stuff like that. So I'm going to have to look into it a little bit more, but I know for a fact that with the dominance, this is how you get double factor dominant and single factor dominant. So I hope you have found this useful. So if you have found this useful and you have enjoyed today's video, then please do hit the subscribe button. It's really important to me that you guys are following along. I have about 80% or so of my viewers aren't subscribed, so please do make sure you hit that subscribe button. If you have liked today's video, then leave us a thumbs up, get the notification bell on, and share this video with someone who you think would find this useful and enjoy my content. So thank you very much for watching, and I'll see you in the next one.